and pray.
Father, King of Kings, we thank you for this day. We thank you for everything you do. Father, Lord of Lords, we request you to please help us during our physics lessons. Please help us to understand and concentrate so that we may attain the knowledge that we need. Father, King of Kings, bless our teachers and help them to continue teaching us, and please protect us during this pandemic. In your mighty name we pray and we believe. Amen.
Thank you so much, Kaitesi, for that wonderful prayer. I would like to welcome everybody on board. We can see the number is still small, but we are optimistic our friends will be getting in. We'll keep admitting them as they come. So, dear students, my name is Richard Chakonye. Yes, and today we are starting our new topic. The topic is the particulate nature of matter. Actually, basically, states of matter. That's what you call it, states of matter. But you can also call it particulate nature of matter. So we know that you have covered a substantial amount of this topic in chemistry because it's all science, and the knowledge cuts across. It's the same knowledge that moves from physics to chemistry. The principles are basically the same. So we'll need to know your experiences as far as this topic is concerned. So, states of matter. Maybe you could start by asking a question. Let me start by asking a question. Anybody who has an idea? How many states of matter are there? Somebody tell us how many.
Excuse me, Joe, I can't hear you.
Okay, the question was, how many states of matter are there? May someone tell us?
Yeah.
Travel, unmute and submit.
There are 4 states of matter.
There are 4 states of matter.
Yes.
Okay. Kirabo, could you go a little bit more and tell us what these states are?
There are solids, liquids, gases, and plasma.
Okay. Plasma. Okay. Anybody who can tell us a little bit more about each of those states? What do you know about the solid state, for instance? What is there? What distinguishes the solid state from the liquid state? Can I hear somebody say something here? Queen. Queen, can you say something about what you know about what distinguishes the solid state from the liquid state, for instance?
Queen, unmute and submit.
The solid state of matter has its particles closely packed together, while the liquid state
Thank you very much.
The liquid state has its particles, but they're not packed together like the solid state.
Okay, very good. That is the one distinct difference between the two. Any other person to tell us another difference that is there?
Akubuziwe, unmute and submit. Elizabeth, unmute and submit.
The solid state, the solid things in solid state keep their shape unless it is broken or burned. Yet the things in the liquid state take the shape of the container.
Okay. Thank you. By things, I mean, what do you mean by things?
I mean,
liquid state. Bali some states of matter.
Okay. Thank you. Anybody giving us another difference that is there between liquids and solids?
Okay, we can see Charity, unmute and submit. Charity, unmute and submit.
Yes, teacher, I also had the same answer that solids do not change their shape, while liquids take the shape of the container where they are put.
Okay. Thank you very much, Charity. Okay, I want somebody to tell us what they know about the plasma state. What do you know about the plasma state, members? Somebody tell us about the plasma state. I said
Teacher,
hands up. Nalule Rukia.
teacher, the plasma state has free electrons and ions of an element ion. Ion, yes.
Okay. All right. Okay. Very good there. Somebody tell us about gases. What do they know about gases?
Mirembe 1P, Mirembe unmute and submit. Okay.
Gases, their molecules are always in movement.
They are always in movement. Okay, what makes it them to be, what makes the molecules of gases to be always in movement? Somebody else could say something there as well. We want to engage as many as possible.
Divine unmute and submit. Divine Grace.
The kinetic energy.
The kinetic energy. Okay. Thank you, Divine. Any other person who might tell us why the molecules of a gas are always in motion?
Crown unmute and submit.
I think the intermolecular forces are weak, so there's no kinetic energy.
Intermolecular forces are weak. Okay.
Mr. Chakonyi unmute.
Sir, I can't hear you.
Mr. Chakonyi unmute.
Okay, sir, thank you. I'm impressed by the level of knowledge that you seem to have about this topic. That's quite impressive. I'm going to play a video here, and then we will just reinforce what you know, and then move ahead.
Mr. Chakonyi?
Yes, sir.
Mr. Chakonyi, a minute.
I can hear you, Mr. Senjobe.
These girls we are talking about, matter is made up of things are far apart and the things are very close together. So what things are those they are talking about? Can they be specific? What are those things they are talking about? I think they know them from their different subjects matter.
Okay. You had a question, members. Can you tell us what you specifically mean by things in each of those cases that you were mentioning?
Lina Jueji, unmute and submit. Lina?
Yes, teacher.
Have you had a question?
Yes, we mean molecules or particles.
Okay.
Or there's another name. There's another name from your chemistry. Molecules, particles. What is the other name from your physics book? Some of you have even the physics handout. They are given a specific name.
Ions.
Ions, ions are part of is another name.
Maybe we can try Lonkuse. Okay. Yes, Lina.
Lina has gone off. There is another name. These girls have the names. They just forgotten.
Lonkuse unmute and submit.
There are many girls. Can you look Narule? Narule, let's start with Narule Lukia.
Narule Lukia has already answered something. Okay, Narule Lukia.
I think atomic nuclei.
Okay, atomic nucleus. Those are the names, Mr. Chakonyi, we need to harmonize.
Yeah, exactly. Yes. Thank you, Mr. Senjobe. Yes. So I suggest that we play that video first. Then we shall go into harmonizing. Eh?
Yes.
Is that okay, Mr. Senjobe?
It's okay.
Thank you.
Saja concentrating, rotating.
Mr. Who is sharing the screen?
Yes, plasma is the first state of matter in the universe. Wait, what? Is it true? Most people only know about the other three states of matter: solids, liquids, and gases, but they often forget about the existence of the fourth one. So, what is plasma, you ask? Okay, let's take a trip down memory lane when your physics teacher talked about this state of matter. You probably fell asleep during that class, didn't you? Okay, everyone knows that the atmosphere is gas, the ocean is liquid, and the ground we're standing on is solid. These are the three states of matter that exist, and the difference among these forms is the level of energy existing in them. Oh, but that's not all. Plasma is the fourth state of matter on Earth. How come? Well, in a nutshell, you have an ice cube, which is a solid. If we heat it up, the ice cube will melt and dissolve into a liquid. Continue to heat it up, and the liquid will slowly evaporate, transforming into a gas. So, what if we continue to provide heat into this gas? Well, the temperature reaches several thousand degrees, and this gas will be ionized. The vast majority of the molecules or atoms left will only have a nucleus, since the electrons have separated and moved independently. This ionized gas is a mixture of electrons, neutral molecules, and positively and negatively charged ions, which move chaotically. And there you have plasma. Plasma is the first state of matter in the universe because 99.9% of all visible matter in the universe exists in the state of plasma. The sun is a giant plasma. Stars are also luminous spheres of plasma. The lightning that strikes during a thunderstorm or the magical phenomenon of the aurora borealis are also plasma. Only on Earth or some dark planets in the galaxy can you find substances that exist in three states of solid, liquid, and gas, which accounts for only 0.1%. Therefore, plasma is the most powerful substance in the universe. Plasma's application in our daily life is very diverse, such as plasma lights, plasma screens, or plasma cutters used in mechanical factories. Especially a $14 billion NETR arc reactor in France that can produce plasma with up to 150 million degrees Celsius. Speaking of arc reactors, we have to mention Tony Stark's, aka Iron Man's, mini-type arc reactor on his chest. This small reactor, which is only a few pounds, can produce a huge source of energy. This energy converts directly into electricity, helping Iron Man fly up in the air or blast power to save the world. Well, if you believe in that kind of superhero stuff. George Lucas, the creator of Star Wars, didn't really fool you with his science fiction. Remember the colorful lightsaber? Yes, it's plasma. Due to the control of the magnetic field located in the hilt, the arc light has a fixed shape. Is it possible that Goku's Kamehameha also produces plasma? Well, maybe the way Goku awakens his inner power by heating up the air around his palms with extreme heat is the same mechanism which produces plasma. Well, now you know what plasma is. Yes, it's the fourth physical state on Earth, but it's the first state, the Big Boss state.
Okay, Mr. Senyobe.
Sylvester.
I think this video exclusively majorly talks about plasma state, and I thought there was need to place a little bit of emphasis there because it's not one of those that were not so much, I think, talked about in primary. So I thought that the learners would perhaps look at it and maybe its applications and things. So from there, we can start moving forward. Mr. Senjebe, I don't know that you have anything for them as far as harmonization is concerned. Mr. Sai as well, and any other person up there.
Okay, thank you so much, Mr. I want us to go by the book now, if we can. Let us go by the book. At least plasma has been well put. They have now a big idea about plasma. When you continue heating, the last state you get after a gas is plasma. And in most cases, it is referred to as the first state of matter, because you move from those states that are far distant apart, and then we move on to gases, then to liquids, and so on, where molecules are more closely packed. So I think now we can share the book, and we go through slowly but surely through our guide of the book. And as we go through the book, we are going to be making simple notes, because we don't need everything, but we shall get conclusions about how do we define matter, how do we define the three states of matter and what composes them. I think that's the way forward, okay?
That's correct.
Who is now controlling the screen?
I think Madam Javera is.
Scroll, madam. Scrolling it again. Okay, do we need that introduction? There's objectives of this lesson? I don't know.
I think it is clear we are talking about states of matter.
Okay.
And we have already brought them out for sure. We may continue. Okay. We may continue.
So we start at the introduction. Mr. Sally, I'm going to ask you to help us pick a girl to read for us that introduction.
Okay, someone has already put their hand up. Mirembe Emily, S1T, unmute and submit.
And please rotate those girls. If you have picked one from T, pick one from the other streams too. So Mirembe, T is done. Mirembe, take over, please.
Introduction. When you're at the lake or river shores or the beach, you see the heaps of sand and water and even feel the air breeze. All these things are different but made up of tiny particles. The study of matter and its states will help you understand this.
Okay, so that introduction is giving us how many states of matter so far? How many states of matter are they talking about? There are?
There are three.
Three. Can you name them?
Solid state, liquid state, and gaseous state.
And those are the three states of matter that are basically around the Earth. I think we have heard from the video. Relatively cool planets, almost, we experience only those three states of what? Matter. But as we go further, plasma becomes prominent into space, isn't it? Have we noted that, girls?
Yes, teacher.
Oh, they are muted. Okay, so our next subheading is they're asking us that question: what is matter?
Mr. Senjewe.
Yes, sir.
I wanted to suggest to these girls that for purposes of proper identification, let them endeavor to indicate their stream so that as Mr. Sally picks them, as you requested him to balance the boat, he can easily know that this is a person from A, from T, from where. So let them indicate their streams clearly for purposes of proper identification and then balancing and not picking the same people at a time. Thank you.
Okay. They can, I hope they have heard and they can do that. I don't know whether they can do this in this lesson, but we want somebody from another stream. What is matter?
Nanyan Zozana, 1K, may you unmute and submit. Nanyan's, yes.
Yes. The question is, what is matter? And saying all the things around us are called matter. Matter takes up space. It also has weight. Matter exists in many shapes, colors, textures, and forms. Water, rocks, living things, and stars are all made up of matter. The study of matter is important because it guides us to classify things.
Okay. So, can we get a definition of matter? Anybody who can give us a definition of matter? How can we define matter?
Okay, let's have someone from 1S who hasn't given something. 1S. Vivian Sandra Alema, unmute and submit.
Matter is anything that occupies space and has mass.
Yeah.
Matter is anything that occupies space and has mass.
Okay, so that definition is acceptable. Matter is anything that occupies space and has mass. Sometimes we use another word that is in our notes. What word have we used instead of mass?
People without streams, you're putting up.
We have used the
Weight.
word weight. So people capture that definition that matter is anything that occupies space and has weight. I think let us stick to the definition that is in the book. Okay, it has weight. Okay, and literally they are telling us that everything that exists around us, including I think us people, humans, we are made of matter. I hope that has been captured. And different matter has different colors, texture. Do we understand what we mean by the word texture? Who can explain what texture? What are they referring to when they talk about texture?
Teacher, I think texture means the kind of surface like the matter has. Water, sand has a rough surface, clay has smooth surface, yes.
Exactly. So some forms of matter are softy, others are hard, others are rough, others are smooth. That's basically what we talk about texture. There are some materials that are soft, they are hard, and so on. You understand? Is that okay?
Yes, teacher.
Yes,
so
teacher.
when we talk about texture, we're talking about the hardness of material, the softness of material, the smoothness, the roughness, and so on. All that is captured in that word texture, okay? And forms, okay? Shapes and forms, water, rocks, living things. So the texture, we're talking about powder form. There are so many things like that, okay? Things that feel soft, that are hard, okay? So basically that's what matter is. Now, we are going through a simple assignment according to that book. List at least 5 different things in the figure which are made of matter. Compare your answer with those of your friends. This is where we're supposed to need that, but we are going to list at least 5 from that diagram, different things in that picture. I hope you can study the picture. 5 different things in the figure which are made of matter. Compare your answer with those. So Mr. Sally, help us capture these girls, 5 different things. What do they see?
Okay, we'll start with Alicia Kasozi. Unmute and submit.
Am I supposed to give 1 or all 5?
Mr.
Give us
Sengebe?
your 5.
Rocks, the sand, water, the trucks behind, is that a lorry? Something like that. And then also the trees.
The trees. Mr. Sally, were you noting? Were they those 5?
Yes.
Okay. Anything extra?
Okay, let's get someone here. Yeah, Angela, your hand has been up. Teresa, unmute and submit.
I wanted to talk about like what we were referring to as things when we were describing the types of matter. So like I think those are called atoms. Yeah.
And an expert thing you identify from that diagram?
Let's see. I don't see it.
Me, I see certain things that have been captured in that diagram. You have talked about trees, etc., etc., etc. Do we see any differences that can help us define which type of, okay, anything that we see that has been mentioned, that there's something that I'm going to read for you. Matter exists in many shapes, colors, texture, and forms. Do we see anything related to what they are talking about?
Yes, because
in the sand of the
because
same
there
color,
is like
if I was to be more strict
because
and
there's
observant, is the sand of the same color?
Yeah. Yes, because there's like grass and at the same time there's sand, and this item and these things don't exactly have the same texture, which makes them like different. Yeah.
Okay.
And this was a disaster.
So I have a feeling that picture has other intentions where you are supposed to be slightly more observant. You have talked about the sun, but I don't think the sun is of the same color. I can see some sand on the left-hand side. That sand appears to be wet. On the other side, the sand appears to be whitish and dry. You understand what I mean? There is grass, there are trees, there is a tractor in the behind, they have different color, blue and red. You understand those kind of observations? The grass seems to be very brown and so on. There's dry, why some dry area. This picture here, it is slightly different from that one. There is no water, but there is sky there. Nobody talked about the gas, but the existence of the atmosphere. Is that okay?
Yes, teacher.
Okay. So I believe that is what they're trying to imply around us, that all the three states of matter do exist. They take different forms, textures, and so on. So can we move slightly down, Madam Javi? I think we have got our list. Okay. Now, the states of matter, we have mentioned these states of matter being solids, liquids, gas, and plasma. And we have that diagram below. So, group express everything, and we want to do that simple exercise. Madam Jeff, I cannot see the question. Okay. You have an exercise there, exercise 3.1, but we want to do it together. Mr. Sally, you are going to help us, somebody to classify items.
May we have someone, Twin Stacy, 1S, unmute and submit.
So I give the solid.
Pick whichever you've picked, any name, and place the solid, liquid.
For the solid, there is a chair, a paper, a stone.
Excuse me, the instruction is pick, for example, water. Then tell us where water belongs. And we give someone else the chance. Don't mention all.
Okay. So a chair falls in solid.
Very good. Mr. Sally,
Okay,
you can pick someone else.
It's Anna S1. Are you there? Unmute and submit. Narule?
A chair. It goes in the solid state.
Someone has already mentioned the chair. Please don't mention what someone else has already mentioned. Otherwise, we may not finish. Pick something that has
thank you so much,
mentioned.
Water. It belongs to liquid.
Thank you, Deborah. Water belongs to liquids. We can have Nakaliowa, Yvonne, unmute and submit.
The fire belongs in plasma.
Yes, Nalvega.
Oxygen goes
unmuted.
Oxygen goes under gas state.
Unmute. Thank you so much. Oxygen goes under gas state. Thank you so much. Someone here hasn't said anything. Mulungi, Krista, Kisha, unmute and submit.
Paraffin goes under liquid state.
Mulungi?
Paraffin goes under liquid state.
Paraffin goes under what?
Liquid.
Okay, thank you so much. Yes, thank you so much. Okay, Katsime Grace Peace, unmute and submit. Grace?
Meat goes under a solid state.
Thank you so much.
Meat goes under a
Wenje?
solid state.
Yes, thank you so much. Wenje, your microphone is open. Unmute and submit. Bamwesige, according unmute and submit.
The stone goes under solid state.
Thank you so much.
Stone.
Okay, Ndagano Queen, Esther, unmute and submit.
A paper goes under solid state.
Thank you so much. It was already mentioned. Is there something that hasn't been mentioned?
There's another question down there.
Okay, we can go to the next question. Someone give us something about the next question. Joy Mary, Wandawa, unmute and submit.
It says in the figure, in the above figure, are there items which are not matter? If so, what are they? What are they?
Yes,
they could be energy.
Mary.
Sorry.
I can't see that question.
Sorry.
Joy Mary still have the microphone.
I can't see that question.
I'm trying to get back there. Sorry.
So that question says, in the figure above, are there items which are not matter? If so, what are they? They could be energy, heat, and light. So I see heat, fire, light, and yeah, those ones.
Teacher Javi.
Yes, please.
Someone give fire under plasma.
Someone gave fire under plasma. I think that is correct.
Okay.
But it is also heat.
Okay.
So it falls under two categories.
So it falls under two categories, yes, and light.
Okay, thank you.
Because Mr. Sally,
yes,
the question had been specific up there. Make a table with 3 columns labeled solid, liquid, and gas, and classify the items indicated. So they were basically falling under solid, liquid, gas. So
yes.
when fire is put under heat, I think it is okay because plasma was not among the columns.
Yes.
Yes, but excuse me.
Yes, Mr. Jakon.
I think it would be better to classify it under plasma. Fire is majorly classified as a plasma. You see, since we have said that plasma is a state, then fire should be there because now heat is the electromagnetic radiation, basically. It's a form of energy in the form of electromagnetic radiation. So heat is not tangible. Heat is not tangible. It is in the form of waves. So I think it is better to classify fire under plasma state. It is under plasma state. Instead of putting it under energy.
It is under plasma.
It is under
that is
plasma,
correct.
but I was just saying regarding this question, you are simply using solid, liquid, gas, and then down here they talked of energy. That is why fire went there, but indeed it is a plasma.
Exactly.
But they put heat also. So I think fire goes under plasma, and then heat goes under heat, light goes under light as energy.
I missed something. I don't know. Did anybody talk about the toothpaste?
The what?
Toothpaste.
Me, I also was off. I don't know what happened to my connection.
No one talked about the toothpaste.
Toothpaste was left there. It is it should be somewhere in between, on the borderline between liquids and gas, solids and liquids, I think. A semi-liquid.
I think it's a fluid.
A fluid of some sort.
It will depend on the toothpaste. There is liquid toothpaste, but there is also solid toothpaste. This one, which is in between, is better classified as a solid.
Okay.
Yes.
All right. Because it can flow, but then it
because
can
it is
flow.
a paste.
So anyway.
A paste is a solid. They are talking about paste. That is a mid. Okay, it is a soft solid state. It's like you are going to talk about powders later.
Oh, it is a hard.
Yeah, but okay. But you see, Mr. Yes, exactly. Because it flows, that means that it should be on the borderline, semi-solid, semi-liquid, eh? Because it has the characteristics of both. It has some shape, but again, we know that its shape can actually change.
Yes. Depending on the container.
And because of that fluidity.
Excuse me, teacher.
Yes, depending exactly.
Would it be okay if I, like in toothpaste, would it be okay to call it like a flowing solid?
Flowing solid.
Like, yeah, like sand.
But
like
you see
sand.
now, if you go back and look at the definition of a solid, when you bring out the characteristics of a solid,
No, I'm saying like sand. Sand is a solid, but it flows.
You go down to the grain, one grain of sand, then it may not actually be able to flow.
Excuse me, teacher.
That is not flowing, must be a state. You can pour sand, but sand does not flow.
Doesn't.
Excuse me, teacher.
Yes, I see where my confusion is coming from.
Excuse me, teacher.
Yes, we can hear you.
The internet says that if you put toothpaste in a container, like after 1 hour you come back, it will harden.
It will harden. In a container?
Because of being in air, open air.
Yes.
The content of the liquid in it evaporates and leaves there solid stuff.
Absolutely. So in other words, you've done some things to it. But if it is to remain in its form, the way we know it, we would want to use it, then it would really be somewhere there. Exactly. Thank you, Mr. Senor. You can proceed, please.
I see something connected to roll call here, S1K, S1 whatever. What are we supposed to do with it?
The girls are supposed to roll call themselves. The girls know what to do.
So I hope the girls know what to do. Me, I'm removing this roll call thing. Okay. We move on, please. Madam Debbie. Okay. What are properties of solids, liquids, and gases? They are giving us an activity. Categories of materials according to their properties. The categorize items according to the following physical properties. So please, I want you to make a list of those properties which they are telling you. What they are giving you. Can it be in your hand? Does it change shape? Does it flow or pour into a heap? Does it flow but not in a heap? Is that okay? So let us look at what we see below here. I think we can go down as we categorize. Okay, we start with the liquid, with the solid. Can someone, Mr. Sally, pick one person to read us for what happens with the solid?
Okay, let's have Someone hasn't said something. Adeke Faith, unmute and submit.
And a solid, it cannot move unless something or someone moves it. It keeps its shape unless it's broken or burned. Its volume stays the same unless it's heated or cooled.
Okay, so if we go back to the above list, what can you say about solids? Can you hold them in your hand?
Yes, we can.
I hope you are in touch with that list. Solids now changes shape.
No, it doesn't change its shape.
Does a solid change in shape? Yeah.
No, it has a definite shape.
So solids have a fixed shape or a definite shape. You have to note that solids have a definite shape. What do you think, what property are they testing when they say that you can hold a solid in your hand? What do you think they're talking about?
Okay, let's have someone to respond to that. Now we got Esther. Unmute and submit.
I'm sorry, teacher, I left my hand up.
Okay, let's give a chance to another person. Okay, someone here, Musubika Thelma, unmute and submit.
Sorry, teacher, I left my hand up.
Hey, girls, now you are leaving your arms up and you're failing to answer the question. Okay, let us move on. We shall get that idea because we have to progress. They'll get it slowly, I think, as they continue to the other, but keep in touch with those 4 points, something that you can hold in your hand. Okay, let me ask it this way. Can you hold air in your hand?
No.
No.
Can you hold a liquid in your hand?
Yeah, but it finally flows away.
Yeah, it flows out.
So you cannot keep it in your hand, it will flow away, isn't it? Now, what makes that solid not escape from your hand?
Its definite shape.
What can you say about its molecules? What can you say about its atoms or molecules?
They are closely packed.
The molecules are so closely tight and they are held by strong forces. That's why they don't escape from your hands. Is that okay?
Yes, teacher.
So the molecules or the atoms of solids are bound by very strong forces that do not allow them to just flow. I hope you get the idea. That's why you can hold it in your hand. Okay, next let us move to the solid. Madam David, go down. Do we pour solids or do they flow? And when they flow into a heap. What do they mean about solids flowing, for example, into a heap? Because this is where people are going to talk about sand. When do they flow into a heap? In what form are they?
I think when they are powder or grain form.
Beautiful. That is when you have crushed a solid into so many tiny particles. You understand? That is the sand. I think that's why you are getting the idea that it can, but those still particles are individual particles. Please, you have simply crushed a solid altogether so that it is now in very tiny forms. Here in class, we always write on the chalkboard, and what do you see after writing on the chalkboard? What gathers below the board?
Chalk dust.
Chalk dust.
Chalk
Is that
dust.
okay? But originally, what did we have? It's a solid piece of chalk, isn't it?
Yes, teacher.
Yes. But after crushing it, it can now flow into what you actually it pours into a heap. The word flow there may even be a little bit, I don't know. In my opinion, Mr. Chakon, you can clarify my colleagues, but I think using the word flow will be wrong as far as sand and powders are concerned. You can simply pour them. Something that flows, that is supposed to be a natural occurrence, that the molecules slide over each other. Is that okay? Naturally. Okay. Its volume stays the same unless heated or cooled. So what can we say about solids and their volumes?
Mr. Njobe, I didn't hear that very well. You were asking me something?
I was saying that using the word flowing in solids, especially when they are in powder form, gives a wrong impression, but I can actually say that solids can be poured when they are in small or powder form.
Yeah, you're right
flowing
about that.
Is supposed to be a natural occurrence.
Exactly. A flow, which actually fluid is that flow. Liquid is gases.
Fluid that flow.
Yeah. Solid, liquids and gases flow, but solids we don't consider them to flow. We wouldn't use that terminology for sure.
Yes. I hope that you got that point. That terminology of flowing is I think erroneously used in our text. Powdered solids can actually be poured, but they are not flowing because something that flows, even if you pour water on the floor, it will continue to spread on the floor. I think you have observed that.
Mr. Senjo, before we continue,
okay,
there's an interesting question in the chat.
Yes.
Which I was wondering, how come we say that solids have a different shape, but when some solids like clay can change their shape? Or do they mean that they can't change their shape on their own? Should I read it again?
You read it. These girls listen to that question.
Teacher, I was wondering, how come we say that solids have a definite shape, but when some solids like clay can change their shape? Or do they mean that they can't change their shape on their own?
Some solids like clay. Actually, let us expand that. Paste. If I put like your toothpaste, it can change shape, isn't it? But what do you observe about a paste or anything like what you're talking about, anything that can be molded? Because solids can be molded, especially that type of stuff like clay, cement, toothpaste, anything that lose shape you can change. It is, we have referred to them, I think, as semi-solid.
Someone here has a name for it. The internet says toothpaste is a colloid.
Yeah.
Colloid.
Yeah, and a colloid, if I may say something.
Yes.
It is the chemists who normally use that terminology, colloid, and it is simply a mixture of tiny particles of one substance that are dispersed evenly into another. Like you have milk in water, or milk, the way you look at milk, it's like you have milk particles in water, you have ink, they are particles of the substance which are put in water to give ink. So such substances, milk and ink, are considered as colloids. Toothpaste is also taken loosely to be in that category as well. But it is neither solid nor a liquid. So that's why I was thinking it is really somewhere in the borderline. So the same thing with the clay as you have put, Mr. Senjove. If you look at clay, if you look at a clay pot, for instance, when the clay has been dried thoroughly, there won't be water in it. Can it flow again?
Yes.
It's a clay pot, but it cannot flow. You can't change its shape because now the water has evaporated. So here, when the substance you have added something to it, then you can not consider that to be a solid anymore. When the clay, and even the clay when it has dried, actually, you won't be able to change its shape. It can only change the shape when it is still in that soft state when you've put water in it. I think they should get a difference there for sure.
Yes, thank you.
Okay. So I hope girls you have captured that point. Can we now move to the liquid? Let us at least complete a liquid. Mr. Sari, select another girl.
I'm here.
Excuse me, teacher. So where do we categorize clay and toothpaste?
No, clay is a solid, only that when you put water in it, then it becomes a paste. But ideally, it should be a solid in powder form. crushed, something crushed that becomes powder.
Okay, what about toothpaste?
Toothpaste, they've elaborated there. It is between a solid.
A semi-solid.
It
You
is a
can even put the word
semi-solid.
semi-solid.
Yes.
For us, it is acceptable.
Yes, semi-solid.
They are semi-solids, especially when they are in that soft nature which can flow. Okay, appear to like you can change their shape anytime. But in actual sense, okay, you can change the shape. Let us say the shape is not fixed. But why? Because you are combining them with some liquid form, and they are in that same state. Either they are not neither liquids nor complete solids, because they are not obeying both properties. That property basically, that's what they are defying, only shape. Okay?
Mr. Sal, I think you can pick someone.
Teacher.
Okay, there's a question.
Is somebody still
okay, there's still another question.
Excuse me, teacher.
What of porridge?
Porridge is a mixture of flour and water. So you've mixed a liquid and with a solid.
Now porridge, because porridge, where do you categorize porridge? Because porridge will depend on the quantity of powder you have placed there. Porridge can turn to porridge, but it will be a mixture still. As long as it pours, I think we shall refer to it as a semi-solid still.
Yes, correct.
Teacher, how about yogurt?
Semi-solid.
That has a combination.
Strict people, let us understand the states now can play around with them. As human, play around with what is God has provided. So even within these very strict boundaries, we can have those things that can go in between. That's what we can at least conclude, isn't it?
That's right.
It's a conclusion. That there are those things that solely fall into solid form, liquid form, and gaseous form. But there is always that transition from one state to another if you interfere with the state. That is human interference, isn't it?
Excuse me, teacher. Excuse me, teacher. We can't hear you. You're very low.
Me, I'm very low.
No, I think the student might have to increase the volume on her gadget because I seem to get you loud and clear from my end here. Let her try to raise.
Yeah, I am on 80 and I still can't hear Mr. Senjove.
So I only hear echoes.
Mr. Senjove.
I can hear you properly.
I beg your pardon, Mr. Senjove.
I can hear you properly.
Mama Senjove, I didn't hear that.
I think we've lost the Senjove.
Mr. Senjove has stepped out a bit.
Okay.
But I think he was saying, for those who didn't hear him, he was saying that there are specific forms, solid, liquid, gas. But if you interfere and mix a solid with a liquid, then it ceases to be either, and that is why we call them semi-solids. And the examples of the porridge, the yogurt, what else was there? All those that
they neither belong to liquid nor they belong to solid because it is a mixture.
Madam Javira. Madam Javira.
I'm back. I think I had been muted.
Okay. Madam Javira.
Yes, please.